All right, in this exercise, we are asked to find and identify the vertex, the focus, and the directrix for this equation right over here. And just looking at it, it looks too complicated. How are you going to get those elements? Well, we're going to take it in 3 simple, straightforward steps. The first thing we're going to do is transform this and put it in one of the 4 general format equations for parabolas. So that's where we have a vertex, the turning point of the parabola, referred to as h and k, which is x and y respectively. Now, the way we're going to do that is by completing the square. By doing that, then putting it in that format, we'll be able to detect and determine exactly what the vertex is, h and k, and also we'll be able to calculate and find the focal length. Once we do that, then we can take those guys, put it up on the number plane, and start to look and play with the elements there, whereby we can describe geometrically where the focus is and where the directrix is. And the good news is, once you complete the square, you'll be able to detect the orientation of the parabola. Is it concave up, concave down, this way or that way? So let's start at step number 1 and complete the square. So the first thing I want to do is get the x's on one side and the y's on the other side. Now, a clue here is that we've got a y squared, meaning that in one of those 4 general formats for parabolas, we're going to have a y squared on the left-hand side. What does that mean about the orientation? It probably means that it's going to be either a parabola that faces this way, to your right, or a parabola faces that way. So that's kind of a clue already, you can tell from the y squared. So let me multiply throughout by 4 so we can equate this. So this will become 4x equals y squared minus 6y plus 13. Let me just write down what we just did. I mean, you can see it, but let's multiply throughout by 4. Get rid of that 1/4 right over there. So now we've got equation 4x equals y squared minus 6y plus 13. I want to take this 13, bring it over this side, so we separate the y's from the x's as I said earlier. So let's take away 13 and then take away 13 from here, which means we'll end up with 4x minus 13 equals y squared minus 6y. Now we can start to complete the square on this side. So to complete the square here, let me walk you through it. We take the coefficient of the y, which is -6, and we divide it by 2, and then we square it. So we take the -6, coefficient of y, there it is, divided by 2, and then square it. Now what's that going to do? It's going to turn it into a -3 all squared. So what's -3 squared? It's a 9. So we add 9 to this side. So what do we do to the other side? We add 9 here also. So 9 to both sides of the equals. Okay, this side's going to be a perfect square. It's going to turn out into y, see that -3? -3 all squared equals, on this side, 4x, -13 plus 9, that's going to give me a positive, that's going to give me a -4. -4, there's an equal sign there. Let's swap these guys so it looks more like that general parabola format equation. So we'll put here y minus 3 all squared, bring that over here, equals, let me factor that, 4 bracket x minus 1. Okay, now it's in the general format for parabolas. Okay, we've got the y squared on the left, meaning it's going to be either concave to your right or concave to your left, and the axis of symmetry will be horizontal. So we got that clue just for that. Now let's have a look at the standard formulas. The one that it's going to be, where we got a y squared here, and that's positive right there. That +4 tells us that's going to be concave this way, to your right. Why? Because it's positive. So let's have a look at the general equation. There it is right there. We've got the y minus k all squared on the left-hand side, which is the same as this. We have a 4a positive, that 4 is positive, and x minus h, that'll be the x minus 1. Now, the h and k are the vertex, the turning point of the parabola. So let's extract those coordinates. So here we'd have x equals 1 and y equals +3. We take the opposite. So it's -1 turns into a, let me just make that clearer, equals x equals 1 and y equals 3. Now how does this work over here? Well, h refers to the x component, so that means h is going to be 1, h will be 1, and k will be the 3. So 1, 3 is our vertex, the turning point of the parabola. So we got one of the elements we've been asked in this question. We got that. Now, let's do a quick calculation and establish what the focal length is. And that comes from that 4. We're going to equate the 4 with that 4a. So let's go ahead and do that. So let's equate them. So that means we're going to get 4 equals 4a. So let me just write that up. So 4a equals 4. So what does that mean? 4a equals 4, dividing both sides by 4. That means a, the focal length, equals 1. Let me write down focal length. Focal length A equals 1. Now, since we know that and we know the orientation is this way, let's start marking things up. Let's first of all put the vertex up there. So the vertex is at 1, 3. 1, 3. There's our vertex right there. Bang. The turning point of the parabola. Now, A equals 1, the focal length. We know the orientation is this way. Let's go that way, 1 unit. So let me just count 1 unit. So we go 1 unit that way, 1 unit across there, which means it's going to be 1, 3. Right there, we're going to have our focus or focal point right there. So let me start labeling both of them. So we have here the focus. Focal point is 2, 3. There's our 3, 2, 3. So let's put it in, 2, 3. And over here is our vertex. Our vertex, and that's the coordinates of 1, 3. Where the axis of symmetry for the parabola goes along there through y equals 3. So now let's mark in, let me just put the A, the focal length. That's A equals 1. We go that way. Let's go A equals 1 this way. Well, if we go 1 unit this way, we end up where? On the y-axis right there. So that means on the y-axis is where the directrix is going to be. So let me just put it on top. The directrix is on the y-axis. There we go, the directrix. So let me just label it. Directrix, and that's at what? That's on the y-axis. That's when x equals 0. So let's summarize again. We have the directrix, we have the vertex, we have the focal point. All we have to do now is sketch in the parabola just so it looks nice and neat. So the parabola will be of this orientation. Its axis goes through here. So let me just put it in. There it goes there, like that there. There's our parabola. Let me just tidy this up now. We have vertex, vertex is right there, and the coordinates are 1 and 3. Let me just tidy it up. There we go, vertex 1, 3, focal point 2, 3, and directrix x equals 0.